Welcome to this presentation on Build Proficiency in Smart Sensor Technology for Industry 4.0. My name is François-Xavier Bellil and I will be your host today. Let's have a look at the agenda. First, I will say a few words about who we are. Then I would like to share with you how we design our learning solutions before we switch to the main subject, which is IO-Link. I will explain what it is, who are the impacted learners, and what type of solution may be available for you to teach it. I will present a short demo of the equipment before we answer your questions at the end. Quick word about the company's history. Festo was founded in southern Germany in 1925. We made the first portable chainsaw in 1927. We were more of a woodworking machine company back then, before we switched to pneumatics in 1955. The didactic branch was started 10 years later, and some 50 years after that, we merged with the US-Canadian company LabVault. We're now in 2020, and Festo Didactic is providing technical training solutions in a wide variety of disciplines, including factory automation and Industry 4.0 topics like we have today. But our portfolio also comprises process automation, fluid power, building system technology, industrial trades, HVAC and refrigeration, as well as a variety of electrical engineering solutions. We are broadcasting today from our business unit located in the beautiful city of Quebec, Canada. In the middle of the screen you have the picture of Mathieu, our product manager for electrical power technology. The training team is on the right. I'm in the middle, and Gonzalo and Christian will be assisting me today with the webinar. I would like to say a few words now about the way we design our learning solutions. The way we do it, we gather a group of teachers, industry specialists, and internal experts to devise a list of learning objectives that are relevant to the subject matter. Using the list, we have technical writers that will sketch the theory and lab exercises. This will lead to equipment specification, and only then do we go get the actual equipment, and we do some testing. We come up with a prototype, and at the end of it, the technical writers will finalize the curriculum, and that's why we call it a learning solution. It's both hardware and software together. Concerning today's subject, IO-Link, I would like to refer you to this amusing video produced by the IO-Link Consortium. It should give you a pretty good idea of what this technology is all about. We will be back shortly for the rest of the presentation. Stay tuned. Welcome back. See now on the right how IO-Link can be integrated into a given plant. Looking at the system architecture, we realize that the information coming from or going to the field devices can be linked up to the control room with different protocols and through various devices such as drives, IO-Link masters, and or PLCs. On the left, we get a glimpse of the standard way a smart sensor is powered with two pins, 1 and 3, and exchanges information on pin number 4. The information transmitted is both the digital signal and additional information. We have here a couple of benefits of using IO-Link compared with traditional technology. First, we have standardized and reduced wiring. The data is more available. We have process data, service data, event-related data. We can configure and monitor remotely. The replacement of devices is quite simple. Finally, we have extended diagnostics compared with that traditional device that we would have otherwise. Now let's see which students would benefit about smart sensor technology. First of all, it's clear seeing the list that we're in the automation world. We have mechatronics technician, electrical technicians, electricians, IT technician, automation specialists. You get the picture. For all of these trades, it's important to have at least a basic knowledge of IO-Link and smart sensor technology in our view. And for these learners, we have created recently the following learning solution. I will share with you this short video showing the system in action, and we will be back shortly after. All right. I was talking with you earlier about the learning objectives that we target during product development. In the case of smart sensor technology, we wanted students to understand the principles of each sensor, to be able to set up network communication, to do some predictive maintenance, to be able to commission the IO-Link sensors, to troubleshoot, to monitor the status of the sensors, to select the right sensor for the right application, to integrate the sensors in a PLC program, to put smart sensor technology in the context of Industry 4.0, and to be able to use the configuration tools provided. We use technology from different manufacturers. You see the list on the right. We have Festo, Siemens, Turk, IFM, Pepperl and Force, and Ressenhauser. These different manufacturers provide the sensors, but we also use different communication protocols to communicate with the master. We have Profinet, Ethernet IP, or Modbus, depending on the configuration. And we use also Bluetooth for our Bluetooth interface. In terms of learning content, it is detailed as follows. In course number 1, we teach the principles, the basic principles of smart sensors. We have 5 lab exercises. In the course number 2, we integrate sensors into PLC programs. For that, we need a PLC. In the following course, it's about the Bluetooth interface. We have 1 lab exercise on that subject. And finally, in the advanced smart sensors, we have 6 exercises, 1 per optional sensor. If we look at the hardware level, the TP1312 that we call smart sensors, it includes 3 basic IO-Link sensors, 1 diffuse photoelectric, 1 inductive proximity, 1 ultrasonic, and 1 IO-Link master to connect with them. We also have the accessory kit, cables, and the tray that are necessary. You also need test objects and a slide unit that may come from another TP if you have it. And you also need, well, it's nice to have the sensor workstation, but it's not mandatory. And of course, you need a computer if you want to do some configuration. So there's that too. And on that computer, you will be using free software. We use the Turk Software Manager as the first step to install the other components. The IODD DTM configurator, it serves as a way to add DTMs, the configuration files for each of the sensors that you will want to configure. And Pactware will be the main tool needed for configuration. And if we look more closely at Pactware, it enables you to assign devices, to assign addresses, and play with the different parameters of your IO-Link devices. So overall, if we look at the structure, we have the TP on smart sensors, and with that we have some curriculum. The sensor workstation, I mentioned that it's a nice to have, but it's not mandatory. If you do have TP1311 on conventional sensors, then you don't have to purchase the target objects and the slide unit. So there's some synergy between the two, and what a lot of people like to do is to teach conventional sensors and move on to smart sensors after. If you're interested into integrating sensors into PLC, that's the second course I was mentioning. If you want to look at the Bluetooth interface, there's that other manual on the subject. And finally, there are 6 additional sensors that are available. They are listed here. And for each of them, we have 1 exercise that treats specifically on that matter. If we look more closely at the sensor workstation, the reason I'm telling you it's a nice to have is because you have the power supply integrated into the station. It can be used as a tabletop or in an A4 workstation. The profile plate on which you attach the sensor is included, and finally you have a multimeter, and you can connect directly with the sensors with the ports that are available on top of the workstation. We have a video on YouTube showing the setup, but I think it's best that we do it together in the demo part of the webinar. So let's take a closer look at the first exercise and its table of content. It starts with an introduction to Industry 4.0. Then we have a series of 5 exercises. The first 2 let you get familiar with different concepts pertaining to smart sensors and the communication protocol. And each of the following 3 exercises is related to one of the basic 3 sensors that come with the basic kit. I will now leave the formal presentation and use our TP1312 with our new digital platform called Festo LX. My goal is to do part of exercise 3 on the inductive sensor with you. We are now on Festo LX on the new digital platform. You see on the left that I have a lot of options. That's because I am a teacher. At the beginning of the exercise, we see that a welcome screen, but we're gonna go straight to this exercise number 3 about the inductive sensor. Let me switch to this view here to see better. Here we go, smart inductive proximity sensors. Let me click to go to the theoretical part where we explain the operating principle, how the magnetic field is behaving when you have a metallic part. And now we see in the animation that we have some metal coming and the inductive sensor is triggered because there's a change in the magnetic field. If we have some wood, it's not affected and the sensor is not triggered. If we keep going, we will see the rest of the theory, but let me go straight to the procedure section. Over here. These are the main steps that we will do if we do the complete exercise, but that's not my goal today. The first part being setting up the station. But first, the general context is we are in a plant where we produce tin cans with beans, and sometimes we have lids and sometimes we don't have lids and we want to reject these tin cans. What we're asked to do is to install the IO-Link master, the sensor, the sliding target base as shown on the picture here. Let me do just that. The sliding unit is already there with the target. I have the IO-Link master, which is connected to my computer and to the power supply. What was missing is this inductive sensor that I will connect to port number 1. And now what we need to do after I finish screwing is turning on the workstation. Good. Let's have a look at the following steps. Yes, all the cables, they are connected, I think. Now, do we have Pactware installed? Yes. Do we have the IODD files? Yes. If we're in doubt, we can go to the appendix. And next thing they will ask us to do is to add the device after we start the communication, connect to the sensor, look at some parameters, and we will be able to read from the device. So let us switch directly to Pactware. This is a new project with only the host PC. I will start my communication DTM for Ethernet. Good, it was added. I double click and I get this window. I will make sure that I have the right network adapter, and then I can search for devices. I find our IO-Link master. We will add this device to the project. You will see it on the left of the screen with its 4 ports. And remember, we have the sensor connected to port 1. Therefore, we will need to add our inductive sensor. You can look on it if you'd like to see what model it is. But I know by heart that it's this one from Pepel and Force, NRB8. Yeah, so I click OK. And there should be a new line. Here we go. With my IO-Link sensor. And I will connect to it. That's why I get the green indication that we're connected. I double click. I see a couple of parameters already. If I go up to, okay, I can restore factory settings first because we're at the beginning of the exercise, just to make sure the parameters were not changed by one of my colleagues. Since we haven't read from the device yet, we will need to click here so we can see the product ID and serial number. See the green arrows indicating that we have some communication going. If I go to the other section, parameters, these are the default ones. We will switch when we get to the rated operation distance. It will be high active, so when we detect, we will have 24 volts, and the stability alarm will be on or enable. If we go to observation, I get nothing, but that's because I forgot to enable the cyclic reading of these values. When I get closer, it goes active. If I move away, it becomes inactive. The device is okay. If I had a problem with my sensor, it will be indicated here. If I go to process data, same idea. I need to enable cyclic read of the process data. Now I'm a bit far away. I get closer, it becomes active. And what I'll do, I will move away from the target until I get to the point where it's not entirely active or inactive. There's some problem with the stability, therefore the name stability alarm. It's just to show you that's one of the things that we do in the book, and that's pretty much it for the demo for today. If you wish to go further, the second course features one lab exercise for each of the proposed CPUs. We establish communication, we integrate the device in the PLC program structure, and we do some monitoring and change some parameters. At the end, we propose a series of optional projects to the students. Course number 3 is about the Bluetooth interface, how to connect it to do some monitoring from a mobile device. We discussed the integration, the process visualization, and the industrial application of such an interface. Finally, course number 4 presents one exercise for each of the following advanced sensors. You see the list here. We have the RFID, the laser distance, the temperature. For the code reader, it's not IO-Link capable because of the bandwidth. It's sort of a camera, but we still consider it a smart sensor because it does some image recognition. And finally, you have the flow and the pressure sensors from Festo. It's now time for additional questions.
Hello, Francois. I have a question here. Okay, so the question that I have here is, Is the system available in a big package with Festo LX, or they are sold separately?
The Festo LX is the new platform, the learning management software that we have. For those who are familiar with what we had with Festo and LabVault in the past, it was called, and it's still called MindSight, but Festo LX is the new one on which we port the new courses that are developed, such as the one on smart sensors. So that's why today we had, I found it would be a good idea to show this this new course with the new material, the smart sensor, because they go well together. You don't have to have a Festo LX. It's a separate bundle. If you don't have it, you can use regular manuals on paper, and that will work as well. It's just more convenient, and I found it was a good timing for me to show you that. Do we have any more question at this time, Gonzalo?
Yes, right now, the other question is, in our courses, do we have courses for Allen Bradley and Siemens? Can we link this system with the PLCs that we may have in the classrooms?
Yes, so there's one course on PLC specifically. It's sort of the same exercise that we do, but with different PLCs. So if you're teaching PLC programming, you can use, you can integrate the smart sensors and the IO-Link master into your program to go one step further. We really encourage you doing this, but at least we have a basic exercise to integrate it. But then if you want to do some more advanced features and you want to connect, I don't know, an MPS station or other hardware that you have at your school, it's possible to do so.
I have another question here for you, Francois. Is do we have all the material, the manuals, in other languages, or is only available in English?
Maybe Mathieu can answer that one. He's also specifying here through the chat box that we cover Allen Bradley compact logics, but please go ahead, Mathieu, if you want.
Okay, so the just to recap on the PLC question, so our curriculum covers the compact logics, PLC integration, then two types of Siemens, one with an IO-Link card built in, and another one via the Profinet network to the IO-Link master. And we also cover the CECC line from Festo PLC line. For the languages, right now all the curriculum is available in English. We're in the translation process also to have it available in French, German, and Spanish. A few of those are already available in those languages, and we're working on that right now. So they will be available pretty soon.
Good, thanks for your answer, Mathieu. Always good to hear from product management. And Gonzalo, do you see any other questions in the question box at this time?
Well, right now my question box has become really stable, so you can keep on going at your rhythm.
Yeah, so I was thinking maybe we could show your setup if you have it with you.
Perfect.
Yeah, you have a different setup than the one I have next to me. So I will turn off my camera so we can see better.
Yep, so I think you're seeing right now my camera. So here we have the station. I have here several sensors, and what I'm going to do is I'm going to show here my voltmeter, and I can measure the detection range with my device here, my vernier. If I want to switch, for example, my sensors, as we saw in the video, it's really easy. Just grab one cable, and I will change it to another sensor. And Here I have a temperature sensor. Here I have all my connections, my power supply. So everything the student may need is already bundled here in the working station. So with this, you have your power supply, you have your instruments, you can place your instruments, your sliders. Here we have the Bluetooth connecting device that Francois Xavier, sorry, was talking about. So basically that was my small setup I did today to show you how it looks.
Yeah, thank you for showing us, Gonzalo. And I believe that will be it for today. I would like to thank everyone for attending, for watching. Thank you, Mathieu, for your presence and for answering some of the questions. And we will say to you until next time. Thanks again. Have a good one.